So now that you know, generally speaking, what object-oriented programming is and what a class is, what an object is, and how to do a basic design of a class using a class diagram, now we're going to start to get into the nitty-gritty of object-oriented programming, what it means to actually use it, and why we would use it in the first place. So object-oriented programming is built up of three pillars. All right? These three pillars work together to produce this object-oriented style. So the three pillars, are encapsulation, inheritance, and polymorphism. Today we're going to start off on encapsulation. Encapsulation really has two meanings when it comes to computer science. The first meaning is the idea of grouping, to encapsulate something. And this is a grouping of both data and functionality. So we've already seen this in the class diagrams with attributes and behaviors. And the idea is to group this stuff together, so when you want to create one instance of this class, which we call an object, it maintains its own data and it performs the functionality based on its own data. So for example, if we had that player class we discussed last time, it maintains its own data such as its location and its guns and all that kind of stuff, and if it were to move, it would only move that player. So all the other players that are within the entire program aren't affected by it at all. So this encapsulation is the idea of grouping this data to keep it specific to one instance of the object. The other meaning of encapsulation is the idea of data hiding. So why would we ever want to hide data? Well, the main reason is security for the most part. And it's not like somebody's going to break into anything. It's just more safeguarding so we don't accidentally do something as programmers that we don't want to do. So to give you an analogy, a real-world analogy, if you were to walk into a bank and you wanted to withdraw $500, you would walk up to a teller or the machine or whatnot, and you would say, my name is so-and-so, and I would like to withdraw $500. The teller or the machine would first of all verify you are who you say you are. Following that, they then would verify that you have enough money in your account. If all of that is successful, then the teller or machine would go access the money either from the vault or from its repository of cash within the machine, and then dispense it to you. At no time do you have direct access to that money. In the world of programming, it's the same idea. You may request access to the data, but something on the other end is going to decide whether you have access or whether you can even change or even know that that data even exists. So if you have access, it will retrieve that data or even let you change it if need be, and then you can then manipulate that information however you see fit. Rarely will you have direct access though. So this idea of encapsulation is to protect our programs. So let's say, for example, in a program where you have a ball bouncing off the screen, bouncing up top, bottom, left, and right. If you were to move that ball, you may call a function of that ball called move, and you would pass in a certain amount to move by. And that ball, that move code would then verify to see whether that move was actually allowed or not. Does it cross a boundary or is it still within bounds? If it crosses a boundary, then it may not actually do the move. So this is the idea of hiding the data, or hiding the data so we can't directly just change the location of the ball. It verifies that the change is safe. So that's really where that comes into play. So this idea of encapsulation, the idea of data hiding, and the idea of grouping is what we're going to go into today. And we're actually going to put this into functionality. We're going to do that using what we've already seen so far, which is a basic class diagram. And we already designed a few of them. And the other day I asked you to design the 4 classes that would be required to make the game kaboom. And you came up with the world class, the bomb class, the player class, and the bucket class and the enemy class. In those 4 classes, we're going to build one of those in actual code form today to see what it actually entails. Whenever we're building a class in an actual project, we really need to implement 4 pieces. And those 4 pieces, 4 pieces or 4 parts of every class are as follows. First and foremost, you have your attributes. So this is your data. After your attributes, you have something called a constructor. We'll get into detail about what this actually means in a second. Following your constructor, you have your accessors and modifiers. Again, we'll get into the detail in a minute. And then you have your basic behaviors. These are the attributes and the behaviors are the data that we outline in our class diagram. The constructor and the accessors and modifiers, they're kind of inherent in the program itself, and they're kind of built as we go along. So let's go build our first class, but we need to see what our class is going to look like first. So I quickly drew up a class diagram of the bomb class. So we have the bomb class, and it has 4 attributes. Its image, its rectangle bounds, its Y speed, since they're always falling vertically, and its state. So maybe it's in the active state, the inactive state, or maybe it's exploding. And then it has 3 behaviors. Update, so this could move it along the screen. Draw, which will draw it at its current location. And start explosion, which would initiate the explosion state and all that animation, all that kind of fun stuff. So we're just going to do the skeleton of this for the most part. We're not actually going to implement the finer behaviors or whatnot, because that's really not the point. So going over to Visual Studio, we see basic Visual Studio here with a project called Kaboom. Now I'm going to actually create a class, and to do this I right click on the project and say Add Class, and it's going to give me an option of what I want to call it and whatnot. I'm just going to call it Bomb, because that's what my class diagram told me to call it. So we see the basic form of the bomb class, and this is the empty skeleton. There's nothing in here. So again, we need to add our 4 parts. So I'm just going to quickly add some documentation of where these 4 parts are going to go so you can see, but we can erase this documentation later on. So we would have our attributes, then we would have our constructors, and then we would have our accessors and modifiers, and then we would have our behaviors. So we'll get into the detail of this as we start the next module.